Today we'll be looking over one of the most fundamental, important, and basic tools that Python has, which is Numpy. So what is it? Numpy is a package used for calculating arrays and can process linear algebra. This means it's the basis for image recognition, deep learning, classification, PCA, SVD, all sorts of stuff and all topics that you might be interested in. And moreover, it's kind of similar to list in that you'll get to see it in later codes, but it's really similar in its form, but it can be processed in a much faster pace because, well, to briefly mention it, lists are composed of not only integers, not only numeric forms, but strings and all sorts of stuff, right? So there has to be these information that directs like this list is composed of strings and integers and all sorts of stuff. But Numpy sets it as its basic form. It's just numeric, so it doesn't need that much of information within the code. So Numpy is about like 4 to 5 times faster than just using lists. That's why people use it so much. It's fast and it's accurate and it's powerful in n-dimensional arrays as it's described in its webpage. So, like I said, Numpy is kind of like the fundamental tool. So it is used as a basis for lots of important packages that we're going to be covering, such as pandas. So this will be covered in the next video, which is used for data analysis and manipulation. And all data are in forms of array, which needs Numpy to control it. So if we look at the bottom right part, we can see that this is one of the data frames, but we don't have to understand it just now. You can just see that all these data are in forms of matrices. So if you want to calculate anything from it, we're going to have to use Numpy, which is used for linear algebra. Next tool I'm going to mention is Matplotlib. It's used for data visualization, and it's quite similar to MATLAB if you've ever used it before. So if you are in like engineering department, you're probably gonna have experience about it, but well, it doesn't matter that much. So Matplotlib is often used with pandas and sklearn. So it is used for like regression, classification, and all those stuff. And Numpy is the basis package for the package Matplotlib. So from now on, we're gonna look through the basic codes and how we're gonna use Numpy in our exercises. So let's move on. Alright, so now that we know why we have to know about Numpy, let's try some basic code with it. So first we should import Numpy to use it in further codes. Import Numpy as np. So np is used globally to call Numpy, so you could do it whatever you want. It could be a, b, whatever you want, but most people use np, so you better stick with it. And the most basic function, we could create an array. Say a equals np.array. First I'm gonna make it one-dimensional. Wait, run. If we call a, it's going to return a one-dimensional array. B equals b.array. If we say like this, it's going to return a two-dimensional array. Yeah, it depends on the number of brackets. So if you want three-dimensional, obviously you're gonna have 3 brackets. But yeah, and you're definitely gonna need another bracket here to put values in the third dimension, and it's gonna return a 3-dimensional matrix. So you can create n-dimensional matrices using np.array. And then if you want to check how many dimensions that array you could just call a dot n dimension, and then it's going to return the number of dimensions. So B is right now 3-dimensional. You could go on 4-dimensional, 5-dimensional. It doesn't matter. And if you want to know how what shape a certain array is, you could just call a.shape, and it's going to return how it looks. So it's a 1-dimensional array. Yep, with 2 variables in it. Let's say B shape, 3-dimensional array. Yep, like this. 1, 3, 2. So it means 1 times 3 times 2. And there are 3 dimensions, so that's how it looks. And then let's say let's put this a bit longer so that we could use it in further codes more easily. 1, 2, 3, 4. It's hard to see the differences if like the array is so small, and I don't want to use like BCD so often it gets confusing. 9, 10, 11, and 12. Yep. This is our A array from now on. What we want to do is indexing specific elements. So we want to call, let's say, our first row or first column or a certain element. So if we look from here, we could define it as this one, this one, this one. So if we want to call a certain element, we could input the respective row and column. So, no, by professor, say A, row, column, it's going to return 12. So this one, 12 is on the 3rd row, 3rd column. What am I saying? 3rd row, 4th column. So you know how like Python numbers work, one larger than what you input. So it's gonna be 3rd row, 4th column. Yeah, so it's 3rd row, 4th column, 12 over here. If you say 2, 2, it's gonna say the 3rd one on the 3rd column. Yeah, that's how it goes. So, and then if you wanna pick a certain row, you could just say a let's say this 2nd row, 1, and this. So if you want to pick a certain stuff, this symbolizes the start value and end value. But if there are no variables on either side, it's gonna bring everything in that line, that row or that column. So say I did this, it's only gonna return 7, which is over here. So this means 3rd to 4th, but it doesn't put 4th inside, so only the 3rd. If we say this, 3rd, it's going to return 3rd to 5th, but not including 5th. So here it's going to only return 7 and 8, 3rd, 4th, and not including 5th, so the 2 variables. So this is how you express choosing multiple elements in row column. I did it earlier, sorry. So if you want to choose a certain column, it's going to be a this. Yeah. 3, 7, 11. The 3rd column, it's going to return 3, 7, 11. Multiple elements, we just saw it over here. So if we set the range, it's going to be, by default, it's going to be like this, but 1, 3, 2, 4. Yeah, it's going to return 7, 8, 11, 12. 7, 8, 11, 12, which is from, let's just print A over here. It's hard to go back and forth. 7, 8, 11, 12 are the 2nd to 3rd row, right? 2nd to 3rd, and then it's going to return the 2nd and 3rd variable. So 2nd, 3rd, 2nd, 3rd. This 2 by 2 matrix is going to be returned from print A. This setting area, right? And with these indices, you could replace the elements within the array. So like here, we have A, and let's say we want to replace these 1, 2, 5, 6 into zeros. So if we say A first and second to first and second equals 0, it's going to return a different A. Yep. So this is what we wanted, making zeros over here. If we replace this with another value, it's going to return a new array with the replaced values, right? Oh, so I was going to try to explain 3D arrays over here. I already mentioned it. Let's say Z equals that. If we have 3 square brackets, it's going to mean it's 3-dimensional, right? 6, there has to be commas over here. Yep. Oh, skip this. Yep. Yeah. Oh, what am I doing? See. So this is how you get a 3-dimensional array. It's quite simple till here, right? Now we're gonna try creating special arrays by using some of the functions within Numpy. So first, we're gonna create an array which has only ones in it. NP, we have to set it ones equal NP dot ones, and we have to define how many rows and how many columns, 6, 7. Then if we print ones, it's going to become a 6 times 7 dimensional matrix with only ones in it. Same here, all zeros, we want an empty array. Then we say NP zeros equals NP dot 0. How many? 4, 10. If we print zeros, it's going to print out a 4 by 10 matrix with only zeros in it. And if we want a certain dimensional of a matrix with the number we want, we have to do want equals NP dot full. It's going to be first rows and columns and the number you want. Of course, it's gonna work. It's not gonna work if I just type it in like this. So rows 3, columns 20. The number I want 7, lucky 7. And then if we print out want, it's gonna print out a 3 times 20 dimensional matrix with only 7 in it. So this is how you make a matrix with only the numbers you want. And then if you studied matrices before, you're going to know that there are identity matrices and transpose matrix. So I'll not be going over how to do linear algebra over here, because that's not what we really need to do. The only thing we have to do right now is just get to know what functions there are in Numpy, and if you want to try to use something, you could just Google it. You don't have to memorize it. We don't expect you to memorize it. The only thing we need is just knowing that this is possible using Numpy, all right? Because you're not going to be coding everything using Numpy. When you use pandas, everything is just brought from Numpy. You don't have to type in anything in Numpy, but they just process it for you. So just getting just understanding how it works is all we need. The identity matrix is made with np.identity, but this is kind of an old code. It's not really used that much nowadays, I guess. one identity equals np.identity for ident. Then it's going to return an identity matrix, which is 4 times 4. But see how I only put in 4 over here. I didn't put 4 times 4, which gives me an error because identity matrices are like by itself an n by n matrix. So you don't need to know both rows and columns. Just the number of rows is number of columns. So that's why it only takes in one variable as this inside this bracket. So this is an O code. So people replaced it with a shorter one, np.I. It does exactly the same stuff. It doesn't matter which one you use, but I prefer I because it's much shorter and yeah, it's easier. And then transpose matrix. Let's bring back want from up over there. If you say want dot t, it's gonna return a transpose matrix. So grabbing this side and pulling it over here, in this direction, makes the transpose matrix, which changes the reverses the rows and columns. And then what we're gonna do is trying to generate random decimal numbers. Let's say decimals. Rand decimals. Well, it really doesn't matter what you set the name of the variable as, but np.random .rand and rows and columns will return you a 6 times 3 matrix with random decimals. Oh, I made it too long. Yeah, it's going to return a random matrix of 6 times 3. Now we'll move on to creating a random integer by using something named randint equals np.random. So from numpy's random directory, we're going to bring out randint. We type in the start value, the end value, and the size. So size is obviously the rows and columns, and it has to be in a form of tuple, 5 times 10, let's say it. And start and end, let's say 5, and end value a 50. And then we print out randint. It's going to return a randomly generated integers of size 5 times 10. And occasionally, I should have mentioned copying an array up over here when I was like replacing the elements of an array. But yeah, let's see. Let's bring back some of the matrices. I want to bring back this one. There's so much on the top, so for my convenience, I'm going to define A as this, and then I'm going to replace some elements from A, B equals A, and then I want a B matrix with the replaced values. So B, what should I say, 2, 3, and 3, 1, 2, 3 equals 9. If we say B, it's gonna return B with the result we wanted because these values have been changed as we wanted it to be. And then later on, we want to use A again, and then if we call A again, it's going to return B. So why does this happen? Here we define B equals A. So now if we say B, it's going to be A. So here we changed it to 9, but actually it's the equal as changing an A. There's no difference because it just directs you right over here to this matrix over here. So later on, if you call A, it's going to return the same value defined as B To prevent this from happening, what we use is aa.copy. This just copies A, not bringing A all together. So we put this away for a while. A is back as it was. B, yep, same stuff, but we put changing B and then return B. It's gonna return the value of changed B. If we print A, it's gonna print the original A. So nothing has changed on A. B is only the one we wanted to change. So this is how it works for copying an array. Next up are some just basic math using Numpy. It's just matrix addition, subtraction, multiplication, division. So let's define a new matrix. Matrix equals np.array 2, 4, 6, 8, and 10. If you want to add certain value to all of those elements within the matrix, you just say matrix plus 2. It's going to return something. Each respective values are added by 2. Say 10. 10 larger. Yeah, that's how it works. Subtraction, exactly the same. Matrix minus 9. Yep, 9 smaller than the original array. Multiplication. Yeah, you know how it works. Matrix times 10. Exactly as we wanted it to be. Matrix divided by 20. It's going to return like this. And we could add matrices to matrices. So, and in order to add matrices, the size of the matrices have to be same. So let's bring a new matrix. Matrix 2 equals np.array. The dimensions have to be same as well. 2, 4, 6, 8, 10. 1, 2, 3, 4, 5. Matrix 1 plus matrix 2 will return each values added to each values within the matrix. So this is same as the list, but like I said before, it's just much more computationally efficient. Yeah, and these are just the basic functions of Numpy. Well, exponents are possible as well if you want to. Yeah, it just works exactly fine. And as an exercise, try making this matrix over here, except these A, B, C, Ds, and 1, 2, 3, 4 is just rows and columns. Try making a 6 by 7 matrix with the values like this. Not by typing in every single stuff, 1, 1, 1, 9, 1, 1, 1, but try to use some of the functions that we discussed, that we covered so far. And that's the first exercise for Numpy. Yeah, and this is just like the basics of Numpy. If you want to use some more stuff using Numpy, try searching Numpy on Google, and there's gotta be a whole lot of code related to Numpy. So Numpy. Yeah, there are so many codes related to Numpy, so it's hard for me, but it's hard for anyone to know everything about Numpy. So if you just Google it, there's gonna be much more methods you could apply to Numpy. Yep, and just try the exercise, and that's it for Numpy today.